Hey, I'm Kel.
And it's me, Margot. And
We are from the UST Senior High School. So Margot, ano nga palang pag-uusapan natin?
Things na nangyayari in just a snap, like...
Sunog?
Yes, because serious accidents happen in the most unexpected way. Fire, for example, is a result from chemical combustion of oxygen, fire, and heat. And for it to be stopped, fire extinguisher was invented. Here today, we will discuss the concept of fire extinguisher and its applications in real life.
Fire extinguisher is an act of fire protection that extinguishes small fire by releasing either foam, water, gas, or other chemicals, often in emergency situations. Fire extinguishers vary depending on the type of fire. It is meant to tackle and ensure safetyness in different emergencies.
There are different types of fire extinguisher. Carbon dioxide fire extinguisher contains carbon dioxide in a liquid form. And when the extinguisher let off the liquid part, is set into the air, neutralizing the oxygen that the fire is feeding on. Water fire extinguisher, on the other hand, penetrates the burning materials and create cooling effects that prevents the reigniting of the fire on a certain object.
Powder fire extinguishers eliminates the heat from the fire triangle, thus making it versatile and used on fires involving solids, liquid, gases, and electrical apparatuses. Foam fire extinguishers is the most suitable for flammable liquids and breaks the interaction between the heat and the fuel. Lastly, wet chemical fire extinguisher is best used for fires involving kitchenware, as it cools the burning oil and forms soap-like solutions.
Grabe no, Kel? Ang dami palang fire extinguishers.
Paano nga ba gumagana ang isang fire extinguisher?
And in chemistry base for that matter.
Basically, the fire extinguisher follows the principles of Boyle's law and Gauss law. When the safety pin is pulled out and operating level is pressed, a rod attached presses the spring-mounted valve down to open a passage to the nozzle containing the compressed gas. When the nozzle releases compressed gas, there is a pressure applying downward on the fire suppressant material. Results to the material, the volume, flowing up through the siphon and out the fire extinguisher, which follows the Boyle's law. Also, it is also evident that the size of the fire extinguisher is small. There is a need of higher pressure to release the fire suppressant material in relation when the pressure is decreased upon opening the nozzle. The gas will be expanded and cooled down, creating frost when released outside the tank, which follows Gauss law.
Hello, I'm here today to solve some gas equation. Here is number 1. It concerns about Boyle's law of pressure and volume. An accidental fire in the kitchen started from one of the gas stoves. The executive chef picked up a wet chemical fire extinguisher that can hold up to 2 liters. The extinguisher was filled with a chemical solution up to 60% capacity and pressurized to 110 pounds per square inch. The chef used the fire extinguisher and released about half of the solution. What is the final pressure in millimeters of mercury after the extinguisher was used? Here's a small illustration of the problem. In the 2-liter fire extinguisher, 40% was gas, which is simply 0.8 liters, and 60% was the solution or the wet chemical solution, which is 1.2 liters. After it was used, the 1.2 liter of solution was halved, so minus 0.6 liters is equal to 0.6 liters. Now it only occupies about 30% of the 2 liters. Now, the space that the gas occupies is 70%. That came from the original occupied space of the gas, then plus the space that was freed up upon the use of the fire extinguisher, which is half of 1.2. Now add them together and equals to 1.4 liters. So we're given with P1 is equals to 110 psi, P2 is a mystery, V1 is 0.8 liters, and V2 is equals to 1.4 liters. Boyle's law states that P1 V1 equals to P2 V2. Before before anything is done, we first need to get the desired unit of the answer, which is not psi, it is millimeters of mercury. So we need to convert 110 psi like this. In 1 psi, there is 6,894.76 pascals. Then in 101,325 pascal, there is 760 millimeters of mercury, which is equals to, when you put it in the calculator. Now, you just need to transform the formula to get what you need. And what you need is P2. Now, P1 is equals to this number, which is 5,688.644,816 millimeters of mercury. Then V1 is equals to 0.8 liters as per the illustration. Then P2 is a mystery. Then V2 is equals to 1.4 liters. Now, for you to isolate P2, you must cancel out 1.4 liters, which is what I did here. I divided it by 1.4 liters. Then whatever I do here, you must do to the other side, so no value will be added or subtracted from the total equation. Now when I put this into the calculator, I will get a final pressure, or P2, of 3,250.654,181 millimeters of mercury, or simply 3,250.65 millimeters of mercury in two significant figures.
Once again, I'm Kiel
And I'm Margot of Group 6
from 12 Health Allied 19.
Bye-bye!